Hello everyone, how are you all? I hope you all are fine. So welcome back. Today we are going to discuss the numericals on the density of the unit cell. We have already discussed about the density of unit cell, that how we can calculate, about the formulas and other things we have discussed in the previous video. Okay, so you can check from there. Now today we are going to solve some numericals related to the density of unit cell. That is very important and usually come in the board examination. So we'll see here the numerical number 1. Now sodium, that is Na means sodium. Sodium crystallizes in BCC with edge length, means there is a BCC structure in which sodium atom is there. Sodium crystallizes in BCC with edge length 4.22 angstrom, and you have to calculate its density. Okay, so what is given here, that is sodium metal, the metal name is there, that is sodium is there, and it is crystallizing in the BCC with edge length 4.22 angstrom. Then calculate the density. Now what you have to do, first of all you need to write the things which are given to you. Okay, so one by one we are going to write. First thing which is given here is sodium metal, and the molecular mass of the sodium metal, as you all know, is equivalent to 23. Okay, we can use 23 gram. So sodium atom molecular mass is there, that is given equivalent to 23 gram. Then what is given? The value of Z is given. Z you all know, that is the number of atom in a unit cell. As it is a BCC structure, so in case of BCC the value of Z is going to be 2. Okay. Now what is the other thing given? The value of edge length is given to you, that is the third thing, value of A, that is edge length. Okay, and that is given as 4.22 angstrom. Sometime it will be given in angstrom, sometime it will be given in centimeter, sometime it will be given in picometer, PM. So we need to always convert this value into the centimeter unit. Okay, so how we are going to convert, we'll see later. Okay, I am writing it here, the relationship, like 1 angstrom you need to convert it into centimeter, like 10 raised to power minus 8 centimeter it will be. Okay, now so these are the values which are given to you. One more thing which is always given to you, that is the value of Avogadro number. Avogadro number already we have discussed, will be denoted as Na. So it will be equivalent to 6.022 into 10 raised to power 23. So these are the given value. Now what you need to find, what we have to find, you have to find the density of the sodium which is crystallizes in BCC. So basically you need to calculate the value of rho. Okay, so first of all we will be writing the formula for finding the density of the unit cell. So formula for finding the density of the unit cell was Z into M upon Na multiplied by A cube, that is number of atoms multiplied by molecular mass divided by this number Avogadro number, and it will be the multiple of the edge length cube. So one by one we are going to put its value. Like the value of Z is already mentioned as 2, molecular mass already mentioned 23, then the value of the Avogadro number we all know, 6.022 into 10 raised to power 23, then edge length is there. Now edge length we are going to convert it into centimeter, so it will be like 4.22 multiplied by 10 raised to power minus 8, because you need to convert it into centimeter whole cube. Okay, so like that you are going to put all the values, and then you need to do the calculations. After the calculation you are going to find the answers. So when you are going to write the answer, always write unit. Okay, that is very important, because otherwise marks will be deducted. So the final answer will be coming here around 1.03 gram per centimeter cube, as the molecular mass we have used in gram, and the density edge length is in centimeter, so it will be in gram per centimeter cube. So That is how we can calculate the density of the unit cell. Now you may be getting the similar type of the questions where maybe sometime, like in this case, the density was you have to calculate. Sometime density may be given, you have to calculate the value of Z, means they will be asking that what type of the crystal that is it is. Like suppose if the value is coming around 2, so you will say it is a BCC. If the value is coming around like 4, then you will be saying it is a FCC, that is. Okay. Then maybe they can ask about the molecular mass. They will not give the name of the element, and then you have to identify the molecular mass of the substance. Then maybe they can ask for the edge length. So one of the things will be definitely missing, and you have to find that thing by using the others, because the value of the other things will be given to you. Okay. So that type of the question will be coming from the numericals, from the density of unit cell. Now one more different type of a question, little bit different type of a question, although based on the same formula, but it's a little bit different type. So we are going to see that. Now the second question is there, an element crystallizes in BCC. Again, the element is there, we don't know about the mass because the name of the element is not given. An element crystallizes in BCC structure with edge length 288 pm. Now this time the edge length is given in pm, so we have to again convert it into cm, with the density of 7.8 gram per centimeter cube. It means this time the density is given, that is 7.8 gram per centimeter cube. Now you need to calculate the number of atoms in 200 gram of that element. It means they have given a mass of an element. In that mass, how many number of atoms are there, that you need to calculate. Now how can you calculate that? We all know that whatever the molecular mass of the substance is there, in that molecular mass of the substance there are total 6.022 into 10 raised to power 23 atoms. So if we can find the molecular mass of the substance, we can easily calculate that how many number of atoms are present. So first we are going to use the formula of the density, that is, we all know density is equivalent to Z into M upon Avogadro number multiplied by A cube. Okay, so this is going to be the formula. Now from this formula we can make a relationship, that is molecular mass is equivalent to density multiplied by Avogadro number multiplied by edge length divided by number of atoms. So this is the relationship we are having. It means this is equivalent to the molecular mass of the substance. Now we can make one more relationship here using this only, that is density into Avogadro number into A cube upon Z will be having how many number of atoms? Will be having number of atoms equivalent to 6.022 into 10 raised to power 23. Okay, that is equivalent to Avogadro number. So now we can calculate that how many number of atoms are present in 1 gram. If in this much gram, this much number of atoms are there, so in 1 gram it's like a unitary method. Okay, so it will be like 6.022 into 10 raised to power 23 divided by density multiplied by Avogadro number again, then divided by the edge length, and that Z will be going in a multiple of it. Then in how much mass we have to calculate the number of atom? 200 gram. So in 200 gram of the element, how many number of atoms are there? So we will be simply multiplying the value, that is 6.022 into 10 raised to power 23 multiplied by Z divided by density multiplied by Avogadro number again and H cube, and then whole value will be multiplied with the 200, that is in 200 gram we have to find. Now what we are going to do, we are going to put all the values which are given to you in this calculation. Now it will be equivalent to 6.022 into 10 raised to power 23, okay, multiply by Z. Z means that it's a BCC structure, so the number of atoms are going to be 2 again, okay. Then density, which is given as 7.8, then Avogadro number, which is 6.022 into 10 raised to power 23, then edge length. Now when it comes to the edge length is given in picometer, that is 288 pm. So we need to convert this pm into cm. Now in order to convert it PM into cm, now I am writing the relationship here. You can check that if you have to convert the PM into the centimeter, it will be multiply with 10 raised to power minus 10. That is 1 PM is equivalent to 10 raised to power minus 10 centimeter. Okay. So we will be using that relationship here, and it will become 288 into 10 raised to power minus 10 whole cube. Okay. Then whole value is going to be multiplied with 200 because we have to find the number of atoms in 200 gram. So from this calculation you can see this value can be easily cancelled, and we will be cancelling all other values also. After the cancellation, the final answer will be coming around 10 raised to power 24 approximate. So it means this much number of atoms are present in 200 gram of this element. Okay. Once again I am explaining. In this case they are asking about the number of atoms which are present in 200 gram of the element. So what we have done, we use the relationship that we know that molecular mass of the substance is always equivalent to the Avogadro number of atoms. It means that is 6.022 into 10 to the power 23 atoms. So we have established the relationship to find the molecular mass because we don't know the molecular mass here as the name of the element is not mentioned. So we use that relationship. Now we know that in this much molecular mass, this much number of atoms is there. So in 1 gram, like unitary method we are simply using, like 10 apple cost 20. So what is the cost of 5 apple, like that we are using it. So in 1 gram it will be in the ratio, then 200 gram we will be putting all the values. Picometer PM should be converted into centimeter. That is 1 PM is equivalent to 10 raised to power minus 10 centimeter. We will be putting all these values, and finally the answer will be calculated. So this is some another type of a question which is there. Now this type of the question usually used to come. Okay, maybe some difference is there, like they may be not giving the type of the crystal that is. What is the type of the crystal that is, they can ask. So in that case all the values will be given to you, only you have to find the value of the Z, that is the number of atoms in a unit cell, and then you can predict that which crystal that is it is. Okay. Now the tough problem is that you are not allowed to use calculators. Then in such case, to do or to solve all this calculation, it is going to be a difficult task for you. So how can you make it easy to calculate all these values, to do all this calculation? There is a way that we can use a log table. Okay, we can use a log table to calculate all this thing, but for that you must know that how to solve log. So now we are going to discuss, we are going to see that how we can solve logs. We are going to use log to solve our calculations. Now we are going to see that how we can apply the log and we can make our calculation easy, because as you have seen in the calculations that like Avogadro number is there in a division, so it's very difficult to all this thing, and there is a power of 10 raised to minus 10 and that 288 power cube, all these values are in division, so it's very difficult to calculate. So we are going to apply log to solve our calculation, and it will make our work easy. So first of all you need to learn that what are the different type of the identities of the log which we can apply and which we can use to make our equation easy. Okay, so we'll see one by one. So the first is, like suppose you have a calculation A multiple of B, and then I apply suppose a log in this value. So when I apply the log on this value, the value will become log A plus log B. Okay, so like that it is going to happen. If there is a multiple, you apply log on it, it will become log A plus log B. Okay, then the second identity is there, like if suppose you are going to use any calculation which is in a division like A divided by B, and we have to take its log, that is log A by B, then it will be going to convert it as log A minus log B. Okay, now the third thing is also there. So if suppose anything is in the form of a power, like A is there and its power is B, and we are applying the log in this, then the identity will become B log A. Clear? So like that, these identities we are going to use. Now one more thing students, we can use these identities, but for the value of the log, if any value you are taking for the log, you have to use the log table, and also one more table, anti-log table. About anti-log I will tell you later. How to see those values, I will be making a separate video for that. Okay, so today I am going to show you that how you can apply the log in some calculation. Okay, so but you can remember some log values of a very small quantities like 2 log 2, log 3, log 5. You can always remember. Here all bases are 10. So it will be like, suppose you are using log 2, then log 2 will always equivalent to 0.3010. Okay, then suppose if it is log 3, the value is coming 0.4771. then suppose if it is log 5, you can use value 0.6990. and then suppose if it is log 10, because base 10 is there, so it will be value coming 1. Okay, so these are some common values which used to come in our calculations. So you can remember these values and apply directly in our calculations. So now I am going to do one calculation by using all these logs. Suppose we have one calculation as suppose we have 25 multiple of suppose 50, then divided by 9. Okay, it's a simple value. Now how I will apply the log? Now suppose this is a calculation we have to do, then it must be equivalent to something, like we have to calculate density, so all this calculation will be equivalent to density. Similarly, this value will be equivalent to some variable, so we can use any variable. Suppose I am using a variable called x. Suppose this is equivalent to x. So how I will apply the log? I will write like take log both side. Okay, that is both side we have to apply log. When you apply both side log, it become log x equivalent to log whole 25 multiplied by 50 divided by 9, like this. Okay, now what we are going to do, we will be using these identities. We are going to apply these identities, but before applying I will be doing some more things, like 25 can be written as log 5 square, 50 can be simplified as 5 into 10. Okay, then divided by 9, which can be written as 3 square. Okay, now powers we are going to solve like this identity by applying this identity. So all this value will be now equivalent to like 2 log 5. Log 5 square means b log a power a raised to log a raised to power b means b log a, so it become 5 square means 2 log 5. Then plus log 5, although we can use as 3 log 5 also, the same thing, plus log 10. Okay, and then as it is in a division, like a by b become log a minus log b, so it will be coming as log 3 minus, but as it is a square there, that power is there, so power will be coming here, so it become 2 log 3. Okay, now one by one we are going to put the value. As 2 is there, the value of log 5, what is the value of log 5? 0.6990. Again 0.6990, because again log 5 is there. Log 10 value is how much? 1. Then 2 log 3 value is 0.4771. Okay, when you multiply, add and subtract the things, finally the value will be coming equivalent to 2.1428. Okay, so that is how we have calculated. Now all these values which we have calculated here is coming equivalent to our variable log x. So still we haven't find the value of x, but because we have to find the value of x, not log x. So now what you have to do, you have to cancel this log. So when you have to cancel the log, you have to use anti-log. Okay, you have to apply anti-log. So what we will be going to do, take anti-log both side. When you take anti-log both side, log here is going to be cancelled and anti-log will be applied on the right hand side. So it will become x equivalent to, because anti-log is cancelled, anti-log of 2.1428. Now you have to do what? You have to use the anti-log table. See the value of 2.1428 in anti-log table. How to use, again I am saying, I will be telling you in the next video. Okay. So when you see the value of anti-log here, the value will be coming equivalent to 139 approximate. Okay. The value will be coming around 139 approximate. So that is how we have calculated the value. When you will start applying the log in your calculation, maybe in starting you will find some problems, but once you are habitual of this, you are going to do it very fast. Okay. If in usual way, the same way, means like multiplication division we are going to do, and we are going to find this answer, the answer will be coming in this case around 138.8. So approximate it is going to be same. Okay. So you are going to get marks for that. No marks are going to be deducted for that. Okay. So apply this log when you are going to do such calculation which are very tough, which you find difficult. Okay. It will help you a lot. Okay. How to see the log table, how to see anti-log table, we are going to discuss in the next video. So that's all for today. So don't forget to subscribe my channel, don't forget to press the bell icon, and please like the video.